Okay, great. And how many of you have reviewed the TRM? All of you have reviewed the TRM? Please let me know in the chat box. Yeah, PDF. Okay. And what about others? Have you gone through TRM, Technical Reference Module? Okay, great. So let us try to understand what exactly this TRM and what it is describing, and what are we going to develop from that particular TRM and all. Okay. Yes. So let me show you where you can find the TRM. I hope you have all got access to TRM. Let me show you again where to watch or where to find it out. One second. Let me share my screen. Hope my screen is visible, right? So just you can go to Drive, and in Drive you have something known as PDFs and PPTs. In that, the first one is GPIO controller IP TRM. Okay. Now, in this particular controller IP TRM, we have everything about GPIO controller, and this particular thing we have discussed in great detail in our previous session, right? Now, and the key features and all we are going to discuss in block diagram. I have just given you some basic idea about this particular block diagram. Okay. Now, now let us try to understand what is this exactly doing and all. So you can open this particular TRM parallelly with you. So go to page number 6. Okay. So in page number 6, you have something known as register map. Okay. This is very important. Now, this particular base address is assigned by EXA interconnect during SOC integration. Internally, the register offset is decoded from address 4 down to 2. All the registers are 32-bit wide, 32-bit aligned. Okay. Now, what is this we'll try to understand later, but once let us try to understand one important thing. So what are we going to understand is we are going to try to discuss about this particular file which is known as register file. Okay, so first file which we are going to develop in our project is the register file. Now this register file, what is mean by this register file and all, we are going to discuss. Let me share my screen PPT. Can anyone tell me what are the different functionalities of this particular GPIO controller which we have discussed previously in our session? Anyone wants to answer? What are the different functionalities that we have discussed in the case of our GPIO controller? Waiting for your responses, guys. What are the different functionalities? It controls the pin to act as an input pins or output pins. Okay, that is the very first functionality we have. What is the other functionality? One functionality is direction. It can work as an input and outputs, and UAT and TXRX. Yes. So first functionality is direction. Second one is alternate function. Okay. First functionality is directionality, setting the directionality of the particular pins, and second functionality is configuring that particular pins to be acting as an alternate function. What is the third functionality? Interrupts. Exactly. So whatever the pins they are going to apply as the interrupts, they are going to come to know. Okay. Yes, exactly. And any other particular functionalities do we have? So we have first functionality is enabling or disabling the pins. Next is uh, alternate functions, and followed by interrupts. Okay, and followed by driving and sampling. Now, so let's say if I'm going to have this particular GPIO controller, if I'm going to have this particular GPIO controller with me, In this particular GPIO controller, I'm going to have one thing known as register file. This is what we are going to develop now. Okay. Now, this particular register file is going to have different kind of registers. Okay. Which are of all 32 bits. In this particular register file, we are going to have basically registers. First register, we are going to have all the registers are of basically 32 bits. Okay. We have different registers. This particular register is data register, and it is going to have 32 bits like this. You can store 32 bits. Okay. Next one is you're going to have different type of registers. First one is data register, and you can check it out in the TRM. So go to this particular page number. One second, let me open that particular page. Go to page number 6. In page number 6, yeah. First one is data register. Next one is direction register. So next one is direction register. First, let us try to understand about these two registers. Next, let's move forward to other registers. Okay. This is also 32 bits. Now, let's say suppose if my processor wants to configure first pin, if my processor wants to configure this particular first pin to be output, how processor is going to tell the GPU controller to configure this particular first pin as output? What it is going to do is it is going to configure this particular direction register. So what is processor going to do is it is going to configure this particular pin to be either 1. So if this direction register pin or bit, if it is equal to 1, that means GPIO 1 is configured as output, and if this particular direction register is equal to 0, then GPIO 1 is configured as input. Okay, so if you are a processor and you want to configure this particular GPIO 1 as an output or GPIO 1 as an input, what you're going to do, you need to go to this particular GPIO register file, and in the GPIO register file you need to search for the direction register. And after you have found this particular direction register, what you're going to do is you need to configure this particular bit to be 1, or you need, if you want it to be an output, the GPIO want to be an output, and if it is equal to input, you need to configure this particular bit to 0. Now let's say suppose if I want to configure GPIO 32 pin, GPIO 32nd pin, if I want to configure it as an output, I need to make this bit as 1. Or else if I want to configure GPIO 32nd pin as an input, I need to configure it as 0. So this is how processor is going to tell the controller how to configure the pins as an output or as an input. Is it clear, guys? Is this clear for everyone? How the register is basically working, how it is being configuring the pins as an output or input, and how the processor is going to find out the register and how it is going to configure and all, that is secondary, that we are going to discuss. But you need to know the core logic, what is happening. I want responses from everyone so that we can move forward. Exactly. CPU configures the register. CPU is not going to have the direct access to the pins. It's going to have the access to the registers. So it's going to configure the registers, and controller going to analyze the register content, and it is going to configure the pins as required. Okay, great. Now, so that is what we have written over here. Direction register 0. If this direction register is equal to 0, it is going to act as an input. And if it is equal to 1, it is going to act as an output. And reset state make all pins input, which is a safe power on default. So if you are going to apply the reset, all the bits of this direction register will be equal to 0. That means it is all the particular pins are going to act as an output. Okay. So that is about my GPIO direction register. Next one is my data register. So data register, one output pins direction and alternate. Writing data drives the pad. Reading data reads the current synchronized pad regardless of the direction. So what is going to happen over here is, so if you want to write any particular data, what you're going to do is you're going to update this particular data register is equal to 1. that will basically provide it into the data into the GPIO1. Okay. Now, let's say suppose if I want to write the data into GPIO32. GPIO32 pin, I want to write any particular data. I'm going to make this particular data register bit is equal to 1. When I'm going to write, okay, when reading the process is different. When writing, this is the case when I'm going to write it. Is it clear, guys? This is how I'm going to write and configure configure the particular GPIO pin as an output or in. Okay. Now, let's say if I want to configure GPIO 28th pin to be output, how I'm going to do it? Anyone wants to answer? If I want to configure GPIO 28th pin to be as an output, what is the process we need to follow? Exactly. So we are going to make the 28th bit of our register file, especially which register? Data register to be equal to 1. Okay. Then you are going to make it as an output. And if it is 0, it is an input. So this is important over here. Now, and if you want to drive any particular data, you are going to basically provide this particular data register particular bit to be equal to 1 or 0. So you are going to make it. Okay. So that was about my data register and direction register. Next is interrupt enable. So interrupt enable register setting IE of I equal to 1 allows a pin I to assert GPI IRQ when its interrupt condition configured via I type and I polarity is met. So we will see how we are going to do. But let's say suppose if I'm going to have 32 number of pins like this, and if my processor wants to enable GPIO1 to act as an interrupt. If my processor wants only GPIO1 to be working as an interrupt, not all the pins. We have, like, let's say suppose from GPIO1 to GPIO32, but my processor wants to give access only to GPIO1, not to all the pins, only GPIO1. If there is any interrupt in the GPIO1, then only IRQ should be given to the processor. Okay. If there is any interrupt in the GPIO2, that should not be given as an interrupt to the processor. If we want to have this kind of configuration, what we are going to do is, for that we are going to have another register which is known as interrupt register, interrupt enable register, which is of also 32 bits. And if you have carefully observed, 32 bits where each bit is corresponding to specific pin. So this is my 32 bits from 0 to 31. I can have the indexing, or 1 to 32 also you can have. So let's say suppose if I want to enable only GPIO 1 to be acting as an interrupt, I should provide this bit as 1 and all the bits to be 0. So whatever the interrupts which were applied to your other GPIO pins, that will not be affected to your IRQ. Only GPIO 1 pin, if there is any particular interrupt which is present on the GPIO 1 pin, that will be given to your IRQ. Okay. Let's say suppose if I want to enable all the pins to be acting as an interrupt, then I should provide all the bits to be equal to 1, so that all the pins now are going to sample the interrupt and it will be providing to the IRQ. That is nothing but my interrupt enable. Okay. You're enabling or disabling the interrupt. Okay. So interrupt enable register IE of I. I means I can be 0 to 31. If it is equal to 1, allows pin I. If I is equal to 0, that means pin 0 will be assigned to GPIO IRQ when the interrupt condition is being seen. So what do I mean by interrupt condition? We'll see. So is it clear, guys? Can a pin be output or input and also a interrupt pin at the same time? Uh, Very good question. So a pin should be acting as a output or input. A pin can be output or input. It should act either as an output or it should act as either as an input. And if your pin wants to act as an interrupt, definitely it should be an input only, right? So interrupts you are going to get input to your design, not an output, right? Okay. I will show you what do I mean by this interrupt and how the processor is going to understand the interrupts and all. I will explain you. Okay. Now, this is data register, direction register, interrupt enable register. Now, I have one question for you. Let's say if I'm going to enable all the 32 interrupts, and let's say fifth and sixth interrupt pins are given. Okay. How processor is going to come to know? Is processor going to come to know that fifth and sixth interrupts are being given? Okay, first of all, tell me how the processor is going to. Okay. First of all, tell me how, which, using which signal processor is going to come to know the interrupt has been given or not. Using which signal? What signal I have told you? IRQ. IRQ, is it a 32-bit signal or a 1-bit signal? 1 bit. Exactly. It's a single line, IRQ. It's nothing but OR operation of all the 32 signals, and it's a multiplexed into a single line. Now, how the processor is going to come to know which particular interrupt has been given? Is it a valid question or not? Am I correct? Yes. So for that, what are we going to do is we are going to use one more register which is known as interrupt status register. So this particular register is going to contain the information like which particular interrupt has been given. So if my processor wants to come to know like which particular interrupt has been given, what is processor going to do is it is going to read this particular interrupt, which is nothing but interrupt status register, and you can see the access type for this particular register is read only. For other registers, it was read or write, read or write, read or write. But this particular interrupt status register is read only because the device is basically storing the information of what exactly the interrupt has been given. So processor is going to read this particular information and it will come to know, okay, so this particular interrupt has been given or that particular interrupt has been given, exactly which particular interrupt has been given, it is going to come to know. Is it clear, guys? Using IRQ, it is not going to come to know. Using IRQ, it will come to know that, okay, some interrupt has been given, but what exactly, which particular pin interrupt has been given, if it want to know, it is going to read this particular interrupt status register. And by reading it, it will come to know that, okay, exactly this particular interrupt has been given, that is going to come to know. Is it clear? Okay. So up to this particular register, interrupt status register, things are clear? Great, great. Okay. And so you can see over here, data register is read write, direction register is read write, interrupt enable is read write. And I'm going literally very slow. In GPIO controller only, we are going to take a lot of time for discussing. And afterwards, in the SPA controller, UART controller, I2C controller, all the things will be similar. I don't need to even explain you. You will be reading the TRM and you can able to understand everything. Okay. So you need to spend more time in this particular GPU controller so that the things will be similar in other controllers. Okay. So in other controllers, you need to just focus upon timing and other small parts. Okay. Yes. So this data register is read write, direction register is read write, interrupt enable is read write, and interrupt status is read only. And one more important point over here, if you carefully observe, interrupt status register means a particular interrupt condition was detected on pin I and is pending, and it is sticky in nature. Now, what do I mean by this particular sticky in nature is, let's say suppose if particular GPIO 1 and GPIO 2 and GPIO 3 pins has been given. This GPIO 1, GPIO 2, GPIO 3, this 3 pins has been given. So what is going to happen in the interrupt status register? First bit, second bit, and third bit will be made to 1. Okay. Now, this will not be made to 0 even if this interrupts has been removed. I'm repeating my point again. This particular bits will not be made to 0 even if you are going to remove this particular interrupts. Why? Because let's say suppose if you have sent me a particular message in group or in the Google Meet or somewhere, and I'm busy with some other work, and I haven't noticed your particular message. Now let's say Afterwards, you have deleted that particular message thinking that I have already read that particular message. But what happens? I have not read that particular message yet because I was busy with other works. Now, what is going to happen? Your message will be missed. Okay. So the same thing here is also going to happen. If let's say suppose if the interrupt has been removed from this particular pins, assuming that processor has already read the interrupt status, then what is going to happen? Processor might or might not be reading that particular interrupt, and processor may be missing that particular interrupt. So for that, what are we going to do is this particular interrupt pin bits will not be removed even if you are going to remove this particular interrupts. Okay, so this is nothing but my sticky in nature. Basically, this will be sticky in nature, and when you are going to clear this particular register, for that we have something known as interrupt clear register. Interrupt clear register. Now, what is this interrupt clear register is after processor going to read the particular interrupt. Let's say processor has read the interrupt status, and after reading this particular interrupts, what is processor is going to do is it is going to provide 111 in the interrupt clear register, so that controller will come to know, okay, processor has read the interrupt status, now I can clear them. So after making this particular processor is what it is going to do is it is going to make this interrupt clear register pins equal to 1, and the controller will come to know that okay, processor has read the interrupt status, now I can clear them. So using this particular interrupt clear register only, controller is going to clear this interrupt status register. So that is what it is written over here. So interrupt clear register, write 1 to clear interrupt status register, and if you are going to write 0, there is no effect. Okay, and it is going to clear takes effect on next rising edge of the clock. Okay, so this is what we are going to have in the case of my interrupt clear register. So interrupt clear register and interrupt status register, are they clear? So these two are interconnected to each other. Okay, now is it clear, guys? Shall we move forward? So basically, interrupt logic checks the interrupt register to see which pins have interrupt and make IRQ 1. Then CPU checks interrupt status to see which pins have interrupts exactly. Yes, exactly. And after reading it, what it is going to do is it is going to update ICR register. ICR is nothing but interrupt clear register. So that controller will come to know that okay, processor has read, so that it can clear the interrupt status register. Until till then, it is not going to clear it. Okay. Okay. Now, next is alternate function register. So this alternate function register is going to, if it is equal to 1, then it is going to be disconnected with our data and direction register, and it is not going to act as a normal GPIO pin. It is either going to act as a UART pin, or either it is going to act as an SPA pin, or either it is going to act as an I2C pin. And here, whenever it is equal to 1, we're not going to care about the direction register, and we will discuss about how exactly this alternate function register is going to work. Just for now, remember that if this register is equal to 0, it is going to act as a normal GPIO pin. But if it is equal to 1, it is going to act as either UART or SPA or I2C. That we will discuss. Okay. Next, I type and I polarity also we will discuss. What do I mean by this particular I type and what do I mean by this I polarity? These are basically for detecting my interrupts on the pin. Okay, this we will discuss what is this and all. Yes. So this is nothing but my register file, and how to access this particular registers and how actually the processor is going to access this particular registers and all. We are also going to discuss in great detail in our upcoming session. But what I need you to once go through is I need you to go through up to this particular page. All the signals I will explain you. Once read this particular register description and all, and we will discuss about the other things we will discuss in our next session. Okay. Yes. So any doubts or any queries if you're having, you can stay and discuss with me, or else we can wrap up the session. Okay. Thank you.